If we have two lines that are not parallel, then they intersect each other at exactly one point. And one way to see where they intersect is to just go ahead and draw the graphs. Let's do that for this example. We have two equations here. Each one describes one line. So here's equation 1. It's in slope-intercept form, so we're going to use the slope and the y-intercept to graph it. The y-intercept is at 3, and then the slope is negative 2/3. So negative 2/3, I'm going to think of as negative 2 in the numerator, 3 in the denominator. Positive 3 in the denominator means go right 3 units. Negative 2 in the numerator means go down 2 units. So these 2 points are going to be on our graph. We'll draw the line through those. Our second line is y equals x minus 2. That's in slope-intercept form again. Intercept at negative 2. Our slope, well, we don't have anything multiplied by x. That means we have 1x, which is 1 over 1. So we'll go right 1, up 1, and there's a second point on our line. We'll draw the line through those as well. And we see that those two lines intersect at this point. So the point of intersection is 3, 1. Now, that point is not unrelated to the original equations. Remember, when we say that the green line is the graph of the first equation, we mean every point on the green line is a solution to the first equation. When we say the blue line is the graph of the second equation, we mean every point on the blue line is a solution to the second equation. With that in mind, that point of intersection is the only point that is a solution to the first equation and also to the second equation. We can see that that's really true by plugging in. It is true that 1 is equal to negative 2/3 times 3 plus 3. Negative 2/3 times 3 is negative 2, plus 3 is 1. So that pair 3, 1 is a solution to the first equation. It's also true that 1 is equal to 3 minus 2. So that pair 3, 1 is also a solution to the second equation. When we have two equations that we consider together like this, that's called a system of equations. A system of equations can consist of two or more equations that are to be solved at the same time. That is, we're looking for pairs or sets of numbers that are solutions to all of the equations at the same time. If we do solve a system of linear equations in two variables, the solution to that system is the point where the lines intersect. So that means we can draw the graph and look at where the lines intersect in order to find out the solution to the system. We can also solve the system if we want to know where two lines intersect.